Hello, everyone. My name is Casey Wood. And this is my research on species abundance and occupancy of niche space. So before we get into it, some of you might be thinking, niche space? What's niche space? And I think this deer is in the same boat as you guys. But that's all right. I will definitely get into that. And don't worry, deer. I'll definitely help you out too. So niche space is the physical space in which a species occupies. This includes temperature and precipitation, seasonality and abiotic and biotic conditions, their food resources, as well as the species interactions between species of their own kind and different species. Climate change is altering habitats all around the globe, and these animals are having to adapt and change their areas in which they're living. So where are these animals moving? Well, that's what my research was about. I studied the niche distance abundance relationship, which in basic terms is, do these species of mammals have greater abundance in the core of their niche space, or is it in the outer edges more, or is there none? So the question is, do species reach their highest abundance and occupancy at the center of their niche space? And I do believe that mammals are more abundant and have higher occupancy rates at the center of their niche space. So we set up various camera traps in Schenck Forest and Umstead Forest and left them there for a few months to collect some data. After a few months, we went out and collected them, and we used that data as well as other camera trap data from various camera traps through Snapshot USA from all over the country. We chose 10 mammal species to focus on, ones that were well represented in the Snapshot USA camera trap data and had relatively large geographic distributions. Some of these included Virginia possum, bobcats, and the American black bear. Once we had all the data compiled, we were able to make some graphs in Tableau and actually make sense of the data. We studied the array level occupancy and abundance and compared average occupancy and abundance within core versus peripheral areas of the climate niche. So starting with what we found off with the American black bear. Here in the x-axis represents precipitation, and temperature is represented in the y-axis. The larger the circles here, the greater the abundance, and the smaller the circles, the lower the abundance. Here there is detection rates as low as this bottom left all the way over here. And in the center, it appears that there's the greatest abundance. This graph further demonstrates that indeed, there is statistical evidence to show that black bears are more abundant in their core of their niche space. Now moving on to the bobcat. This graph is much different. There are large circles everywhere, indicating that there's a large abundance all over their niche space. There's no special abundance in the core or the left or south, north. And this graph further demonstrates that there's no statistical evidence that demonstrates that there is any abundance greater than any other area in their niche space. And this was the story for all of them except the American black bear. Why? Well, maybe it's because that they require more resources, and cores of niche spaces typically have greater resources than the outer edges. But this would be an interesting research question. Why do some animals have more abundance in the center of their niche space while others don't? I would like to thank my group mates Kelly Prey, Elaine Savage, Ariane Trotter, and Lucy Kokone. And I'd also like to give a big thanks to Dr. Roland Kays and Alexa Murray. Thank you very much.